Hello. Here we explore the plate boundaries, the boundaries that limits each plate. We're going to focus today, on this lecture, we're going to focus on the divergent plate boundaries. So let's look at the different types of plate boundaries here. We have the divergent boundary. You can see here the plates are moving away from each other. We have conversion boundary where the two plates move close to each other. And also we have what we call transform boundary where the plate move side by side. So let's focus on divergent boundary. So here we have the different types of plane boundary in this map. Here we have, you can look at the arrow here moving away from each other. That's divergent boundary right here. Example would be, for example, here, look at the arrow moving this way and this one move that way. And this is called Mid-Atlantic Ridge right here. We have another one right here, East Pacific Ridge right here. We have other ridges right here, Southeast Indian Ridge, and so on and so on. So you have many example of divergent boundary. So what happened along this divergent boundary? So here again we have two different plates. We have one plate here moving this way, and we have one going this way. So below this, we have a magma coming up, cools off right here, and then becomes a rocks and push the rocks away. So what do you have along this boundary? We have what you call mid-oceanic ridge. Basically, it's the mountain right here. This mountain right here is called the ridge. And here we have faults. This series of lines you see here, these lines right here are called faults. And those are the ones that cause the land to fall down, to move down because of this faults. Okay, so you can see again another illustration again for this divergent boundary. Plate moving away from each other with the magma coming up here and causing the lava to become rock, and finally the push of the rocks that are already formed in there. We have again another slide or cross section for divergent boundary. You can see here the ridge right here, and we have here the lithosphere right here, and finally asthenosphere. So basically all this part right here and this one right here is moving on the top of the asthenosphere. So imagine we have two blocks just to have an idea about how it works. Imagine you have two blocks floating fluid. Fluid is green, and the two blocks here on the top. So we have the water coming up, filling the gap, and causing the blocks to move sideways. And then this is symmetry. So this is exactly what happened along the divergent boundary. We have the opening of the ocean floor here. It becomes wider and wider because the ocean floor is spreading. So let's look at how it works here. So first of all, we have the line, which represents the rifting or the cracking of the land. Then the land starts to move apart, and anytime we have land forming on this side here, also we have same thing forming on the left side. So this one is continent number 1, and this is continent number 2, and from here to here is ocean floor, which is covered by water. So you can see, for example, this ocean floor right here, and the question asking you here, how old is rock here in the middle, right here? Remember what we talked about in terms of when it comes to the age of the ocean floor in the middle as compared to the one next to the continent. So of course the age is zero because remember this is more recent. They are just forming, so the age is zero. So how about the other one here? How old is this one right here? Well, the answer is also zero because they are forming the same place, 0, 0. Um, how about here? The rock here is 60 million years old. How about the rock here? Think about it. Yes, of course. It's 60. If this is that's what we talked about symmetrical age. If the rock here is 60 million years old, also this one is 60 years old. So again, you can see here clearly that there is this kind of symmetry in age. 0, 0, 20, 20, 40, 40, 60, 60. So this is how the process along the Divergent boundary is happening. So we have the sequence of steps from time 1 all the way to time 3. Again, here the same thing. We have this colored ocean floor with different ages. You can zoom out to specifically Atlantic Ocean. You can see also this kind of symmetrical age. And so basically, just to have an idea about what happened from the beginning of this divergent boundary is at the beginning we have what we call rifting. This means that these are both land right here. Imagine this, for example, America, for example, and this is Africa. So what happened is that first we have cracking of the land. That's called continental rifting. Rifting is basically fracturation or like breaking of the land. What happened after this continental rifting? As I said, when this land move away from each other a little bit, what happened is that the water here on this side here fill in the gap, causing the formation of small sea. The spraying will continue, and finally we have a big ocean. Let's look at an example. We have this continental rifting is happening. Well, the best example is here in East Africa, right here, somewhere here. So if you look at this area right here, you can see this continental rifting here. I'm gonna draw this with this purple color right here. This is where the land is today, breaking apart in East Africa, right here. And you can see this motion, this part here is moving to the right, and this one is moving to the left. And as a result, when you move this to the right, and this one is moving to the left. And as a result, when you move this apart from each other, the land here in the middle start to fall, and as a result, lake starts to form. And because we have also lots of volcanoes, we might have mountains or volcanic mountains here, like Mount Kilimanjaro, for example. So what happens if this opens a lot? If this moves and open more? What happens simply is that the water here will fill the gap here, and also the water here gets in. When this happens, this will become similar to the Red Sea, because the Red Sea itself used to be like this. So if this opens, water gets in, and you have a sea. This is again the same example here. We have this volcanic activity taking place, volcanic mountains in this area right here. Okay, this is the area we're looking here, we're focusing in this area right here. That's a best example of East African rifting in East Africa. So again, this is again same thing again. We have seafloor spreading because of all these things keep moving. So you go from continental rifting all the way to sea and finally to an ocean. And here we go. We have the summary of the divergent boundary. Thank you.